Here we'll look at conditional statements. So the conditional operation is denoted with this arrow symbol. And this is read if P, then Q. And a compound proposition that uses this conditional operation is a conditional proposition. This proposition, if P, then Q, is false if P is true and Q is false, and otherwise, if P, then Q is true. So we only have one situation where this is false. Here's the truth table, and you'll see if we move from true to false, we have that the conditional statement is false. A conditional statement expressed as English is sometimes called a conditional statement, as in, if there's a traffic jam today, then I will be late for work. And in this proposition, we call P the hypothesis and Q the conclusion. And we can think of this conditional proposition like a contract between two parties to remember the truth table. So for example, if you mow Mr. Smith's lawn, then he will pay you. The only way for the contract between you and Mr. Smith to be broken is for you to mow the lawn and him not to pay you. If you do not mow his lawn, he can either pay you or not, and the contract isn't broken. So in the words of logic, the only way for a conditional statement to be false is if the hypothesis is true and the conclusion is false. If the hypothesis is false, it doesn't matter what the conclusion is, it will always be true. When we discuss P, if P then Q in English, there's a few different ways to say that. So the first one is if P then Q. If you mow Mr. Smith's lawn, then he will pay you. Another way to say this, if P, Q. If you mow Mr. Smith's lawn, he will pay you. We can also say Q if P. Mr. Smith will pay you if you mow his lawn. We have P implies Q. Mowing Mr. Smith's lawn implies that he will pay you. P only if Q. You will mow Mr. Smith's lawn only if he pays you. P is sufficient for Q. Mowing Mr. Smith's lawn is sufficient for him to pay you. Q is necessary for P, so Mr. Smith's paying you is necessary for you to mow his lawn. So there are three conditional statements related to this proposition that are so common that they actually have special names. The first one we'll look at is the converse. So the converse of if P then Q is if Q then P. So it switches out the hypothesis and the conclusion. For example, if we have the proposition if the game is raining today, the game will be canceled. The converse will be if the game is canceled, it is raining today. The contrapositive of if P then Q is not Q, then not P. So if we have the same proposition, if it is raining today, the game will be canceled. The contrapositive will switch the order and negate each one. So if the game is not canceled, then it is not raining. The third one is the inverse. The inverse of if P then Q is not if not P, then not Q. So this one we just negate both sides. So our proposition is still if it is raining today, the game will be canceled. The inverse just negates each one of these. So if it is not raining today, the game will not be canceled.